Instrumentation. Okay, so already we have discussed the diagram of HPLC instrumentation. So operational procedure and some of the steps involved for the HPLC are as follows. What happens? The first step we are going to do there is that the sample is dissolved in suitable solvent. Sample is dissolved in suitable solvent. Usually mobile phase to be used. So mobile phase आपण वापरणार आहोत तिथे तोच solvent म्हणून आपण त्या ठिकाणी वापरणार आहोत. Okay, it is injected into the system. The injection port is there from which we are injecting the sample from here. Okay, you can see on your screen where the sample is injected. It is get mixed with the degassed mobile phase. Get mixed with the degassed mobile phase. So mobile phase under high pressure flows over the stationary phase in the column where separation takes place based on the differential solubility of the solute in two phases. Okay, so every column is used to saturate the mobile phase with the vapors of the stationary phase. Okay, as a solute comes out of the column, it reaches to the detector placed next to the analytical column. Okay, and it is then get detected using the detector. Okay, over here, see here you can detect your sample. Here you can detect your sample which is coming out of analytical column. Okay, so this is a P column. Okay, we are not injecting sample here. We are injecting sample to go for the separation in the analytical column. So what is solvent reservoir? It may be made up of glass or stainless steel. Okay, and it has a different capacities, like you can use 200 ml glass or a stainless steel container, okay, or reservoir, or 1 liter reservoir. Okay, so they are equipped with a degassing system to remove all the dissolved gases like oxygen, nitrogen, and other gases present in the solvent. Okay, so in the isocratic elution, we use only one solvent for the elution or for the separation. Okay, but in the gradient elution, we are using mixture of two solvent or more than two solvent for the getting good separation. Okay, so the solvent selection is totally depends upon the polarity. Okay, and the most modern instrument a device that transfer the solvent into the mixing chamber at a different flow rate is provided. Nowadays, what happens due to the continuous research and development, the development is happening continuously, and that's why there is some kind of innovation comes out every time, and that innovations are now implemented with the old instruments, okay, to increase the efficiency and to get the better separation of the component by using the technique. Okay, so by using that device you can mix the solvents, okay, and that you can use for it. Okay, so another important precaution required is the removal of suspended material from the solvent. Okay, and that is possible to the filters. Okay, so the remote suspended removes that millipores filters are used that removes the suspended matter present in the solvent. Okay, as well as dissolved gases from the solvent are removed. And that is possible. See, this is what the reservoir. Okay, by using this reservoir we can supply the solvent for the separation purpose. So whole assembly looks like this. Okay, so why such a different number of bottles are here? Because as you know that in the gradient elution we may use 2 or more solvent for getting the better separation. Okay, so that's why such a more number of containers or the reservoirs are there. What is degassing system? ह्या degassing system मध्ये जर solvent मध्ये जर काही तुमचे गॅस असतील ना तर ते रिमूव्ह करण्याचं काम असतं. Okay, it removes the dissolved gases from the solvent. Okay, so dissolved gases are not removed from the solvent bubble formation. Okay, see, if dissolved gases are not removed from the solvent, bubble formation will occur in the column. And what happens due to its solvent get disturbed, that column get disturbed, the creation of gap in the stationary phase occurs. Okay, and due to which it affects for the efficiency of the column and the separation of the component from the column. Okay, that's why we are using degassing system for the solvent. Okay, it can brought about by the vacuum pumping system. Okay, with the proper use of pressure, the solvent vapor can be made to condense and dissolve gases will escape from it. So distillation system with the heating and stirring arrangement are also used for the removal of the gases. Okay, or gas purging is another technique used for the same. Okay, in this case, inert gas of low solubility is used. So fine bubbles of the inert gas are passed through the solvent. This will sweep out all dissolved gases from the system. So it is not necessary to have these devices as an integral part of the instrument. Okay, so degas solvent is filled in the reservoir. That is also possible. Okay, so you can do it. Okay, you can degas it in the another means another flask, and that solvent can be transferred to the reservoir. That is also possible. So it is not every time necessary to have all these things integrated. Okay, what happens due to which that whole system becomes very big and big, and that causes the problem while operating the system. Hence, this can also be done. Okay, so pumps are there. We are also using the pumps. So the pumps, they are the core instrument. Why we are using pump? To create a pressure on the mobile phase which is passing through the column, right? So they make the mobile phase flows over the stationary phase. This requires very high pressure, and the properties of pump to be used in the HPLC are listed below. The pump should be able to deliver a pressure about 600 psi, 6000 psi, pound per square inch. Okay, it should be able to provide flow rate ranging from 0.1 ml to 10 ml per minute. So the flow of liquid mobile phase should be smooth and continuous. It should not occur in the form of pulse. It should be able to provide reproducible rates to the extent of 0.5% or less. Okay, a rate should be reproducible. Okay, it should be smooth and continuous. Okay, it should provide a flow rate about 0.1 ml to 10 ml per minute. Then it should create a pressure of 6000 psi. These are what the things. Now there are the three pumps we are using in the HPLC. First is a reciprocating pump. After that, there is a displacement pump, and one more is a pneumatic pump. Okay, so what is a reciprocating pump? Reciprocating pump. Okay, reciprocating pump. This is what the diagram of reciprocating pump. See, this is what the motor over here, and this motor is connected to the, this is a piston or plunger, you can say. This is a plunger. Okay, here it is a pump head. Now mobile phase comes inside from this side. Okay, this is a check valve over here, comes from inside from this side and goes out from this side. Okay, so the volume here is a, see, 5 to 50 microliter. Now see what happens. This is moving, as this start to rotate. Okay, this will come back, go to this side, come back, go to this side. When it comes back to this side, what happens? It creates a vacuum over there, and mobile phase comes inside. And once it again comes back from this side, okay, so it presses the, push the solvent to the outside. And when it pushes the solvent to the outside, this valve get closed. Hence the name is check valve. Okay, so this comes out from this side. Okay, in the same way, when it goes back, this valve get closed, only this valve get open, and from where the solvent come inside. Means this is a continuous process. When this goes back, solvent comes in. When it comes to this side, okay, in this side, then solvent goes outside of this motor and creates the pressure over there. So solvent introduced is to a small chamber. Okay, a motor driven piston is used for the pumping of the solvent. The back and forth movement of the piston pumps, okay, the solvent, right? The flow of a solvent is controlled by means of valves. Okay, check valves are there. The back and forth movement of the piston develops the pressure on the solvent. Okay, hence the name reciprocating pump is there. Okay, the output of the pump is pulsed, and hence to provide continuous output, it must be damped. It must be damped. To avoid a direct contact with the solvent, a flexible diaphragm is used over here, flexible diaphragm is used. Its movement will impart pressure to the solvent. Most of the instrument make the use of this type of pump. The pump has several advantages, like at a time small volume of a solvent is used, first thing. Then in terms of pressure, output can be very high. The pressure developed can be about 10,000 psi by using this pump. See, the constant flow rate can be achieved irrespective of the viscosity of the solvent. This is what the one more advantage of this pump, okay, or see application of this pump, and it can be readily adapted to the gradient elution technique. Gradient means it can be used for the solvent which are we using for the separation in mixture. Okay, we are using 2 or more solvent for the separation, and in that case we use this pump. Okay, hence the name is reciprocating pump. Okay, I think this is clear to you. Next is the displacement pump. Displacement pump. So we'll discuss about displacement pump in the next lecture. Thank you.